Hello friends, welcome to the video tutorial of C programming, and in this video we are going to study multidimensional array. From last few lectures we are studying one-dimensional array. Now we will start studying multidimensional array. So first of all, we will write the declaration statement for one-dimensional array first to understand the difference between multidimensional array and one-dimensional array. Basically, what is the declaration of multidimensional array? You have to specify the array name, and then after you have to specify the array size. So this size is nothing but what? Dimension. It is nothing but what? Dimension. So how many dimensions you have defined? You just define one dimension. Now suppose if I declare my array something like this, 5, 5. Okay. Now here I define two dimensions. How many dimensions I define? Two dimensions. So this will be called as two-dimensional array. So here I am just writing it in a short form. Here we call this array as what? Two-dimensional array, because how many dimensions we define? We define two dimensions, this one and this one. Similarly, if I want to declare a three-dimensional array, so what will I say? I'll define three dimensions. So this will be called as three-dimensional array. So this 2D array and 3D array are nothing but what? Multidimensional array. Are nothing but what? Multidimensional array. So if you define a dimension of an array more than one, then it will be called as what? Multidimensional array. So here in this course we are going to concentrate on 2D array only. Okay, so we will study how to declare 2D array, how to initialize 2D array, how to take an input for this 2D array, and how to display the content of this 2D array. So let us see this part step by step. So let us see a declaration of two-dimensional array. So how to declare two-dimensional array? First of all, you have to specify the data type, then specify the array name, and then after you have to define two dimensions and the size of that two dimensions. Suppose here I am saying this dimension is of 3 size and this dimension is of size 2. Okay, so basically this 3 represents rows, whereas this 2 represents columns. Okay, and the number of element that your array can store is nothing but a multiplication of these two dimensions. Okay, which is nothing but a 6 here. So this will gives you total number of elements. Here in this case it is what? 6. So basically logical representation, okay, mark my word, logical representation of my two-dimensional array is something like this. So logical representation is going to be a tabular. Okay, so basically we have 3 rows and 2 columns, right? Okay, again I'll repeat, this is logical representation, or you can say it is conceptual representation for our understanding. Basically again in-memory representation is going to be consecutive. In-memory representation is going to be what? Consecutive. So let me draw it also. And this one is in-memory representation. In-memory representation means in memory this array 2D array also acquires consecutive block of memory. Now here for our convenience we represent it in this tabular form. So these are nothing but my rows, whereas these are my columns. Now again, every row has index starting from 0 to less than row size. So since our row size is 3, my index will go from 0 to 2. Here my columns are 2, so it will goes from 0 to 1. Okay, whereas it will be represented something like this: 0 0, then 0 1, then this is the 1 0 position, this is 1 1, this is 2 0, whereas this is 2 1. Okay, so as you can see here, how your memory is allocated row wise. Okay, this is 0th row, 0th column, 0th row, 1st column, 1st row, 0th column, 1st row, 1st column. Look at here. First of all the elements get allocated for 0th row, then 1st row, and then 2nd row. So this is also called as row measure representation. This is also called as row measure representation. Remember this thing. Okay, in C, your array is represented in a memory row wise. In some languages, it may be represented in column measure format. Okay, so if it is in column measure format, so first of all 0 0 1 0 2 0 gets stored, and then 0 1 1 1 and 2 1 gets stored. But in C there is what? Row measure representation. So remember this thing. Now here, to access every element of your array, you have to use 2 indices. For one-dimensional array, what you did? You use only single index. Now here single element will be represented by 2 indices. So let me put some value here: 5, 7, 9, 10, 3, 2. Okay, now just consider that I want this value. Okay, where it is located? It is in 1st row and 1st column. So what you will say? X of 1 1. Suppose I want this value. What I have to say? X2 0. So while accessing or while fetching the element of row element of multidimensional array or 2D array specifically, first of all you have to specify the row index. Okay, and then after you will specify column index. The order should be according to this only. Means first index always represent row index and second index always represent column index. Remember this thing. Okay, and this is a statement to access or fetch your element in 2D array. Okay, so I hope you understand this. Now let us see how to initialize our 2D array. Now let us see the initialization statement. Suppose already values of 2D array are known. In that case we can initialize our array. So let us say x of 3 2. Initialization means what? At a time of declaration, if you assign some value to it. Okay, so how many rows we have? We have 3 rows. So say 15 comma 2. So these are the element of first row. Now here we have totally 3 rows, and every row will contain how many elements? It will contain 2 elements, 9 7 and 6 comma 5. Okay, so look at here how we initialize it. We initialize our element row wise. First of all we define the element of 0th row, then 1st row, and then 2nd row. So let us see the conceptual representation of this array after initialization. Okay, so look at here, this is conceptual representation of your array. So here 15 and 2 are the elements of 0th row, 9 and 7 are elements of 1st row, whereas 6 and 5 are elements of 2nd row. Now there is one more alternative to initialize this 2-dimensional array. So let us see this method. Int x of Again I am going to use same array name and I am going to use same values for initialization, but just I am going to show you how to initialize it in different way. 7, 6, 5. Okay, it will be something like this. So here automatically what happened, your value get filled row wise, means 15 2 will be filled, then after 9 and 7 will be filled on the next row, and then after 6 and 5. So I hope you understand the initialization process also. Now suppose I want to take an input for a 2D array. So let us see that process. Now consider this array X of size 3 by 2. Okay, here I already put some values. Okay, or what we can do, we will just remove this value. Okay, now here we want to input a value for array X. Okay, now while inputting you can take it in any order, means you can take it row wise or column wise, it's your choice. Okay, means suppose I want to take a value row wise, then I have to specify 0 0. Okay, we have to accept the value at 0 0th location first, then value at 0 1 position, then value at 1 0 position, and then 1 1. Then we have to accept a value at 2 0 position, then 2 1 position. Okay, so these are your indices. So as you can see here, see, when your row value is 0, your column value changes from 0 to 1. When your row value is 1, your column again starts with 0 and it gets incremented by 1. And at that time row value is what? Fixed. Okay, when your row value changes, again you are starting with 0. So this is very similar to the pattern program that we studied in nested for loop. Okay, there only we are starting with 1. Here we are starting with 0. That is the difference. That is the only difference. Okay, so here whenever there is a requirement that for one particular value you have to repeat the process n times. Again for that second value you will process the request n times, or to execute an operation n times. Okay, in that case you have to use what? You have to use nested loop. Okay, and if you are not aware of this part of nested loop and pattern program, please watch the video of nested loop and pattern program. I already uploaded that in this tutorial. So I hope you understand this. So for the nested loop we have to use a combination of loop, right? So either you can use combination of while loop, for loop, anything. Okay, basically while loop, basically for loop will be easy because we have a definite start, we have a definite end, and there is a regular interval. So that's why we are going to use nested for loop. So let me rub this part first, and then we will write a code that will take an input from a user. Okay, so for I equal to 0, why I initialize it with 0? Because here my index values are starting with 0, that's why. And here again I am saying less than 3, not equal to 3, not less than or equal to 3. So remember this part also. Now this will represent what? Row. Then for j equal to 0, j less than 2, and j plus plus. Okay, how many rows we have? 3 rows. And how many columns we have? 2 columns. Now let us display a message to the user that enter element, and then after we will scan the value of our array element. So scanf %d, again ampersand you have to use, then your array name, and then you have to provide the subscript value. Okay, now look at here, when your I value and j value is 0 0, whatever value you will scan, it goes at 0 0 location, then j value get incremented. I remains 0, j value get incremented, it will be 1. 1 is less than 2, so condition satisfies. Now whatever value you will enter, it will goes in 0, 1 position, because now j changes, a naught, sorry, not I. Okay, when j becomes 2, 2 is not less than 2, it is equal, so condition evaluates to false, and then I will get incremented, I become 1. Okay, so basically how this loop executes, when I value is 0, j will starts with 0, then j will be 1, and when j will be 2, condition will be what? False. At that time I value is 0. Then I value get incremented by 1 and j again start with 0. So 0, 1, and when it becomes 2, it will be false. So at that time value of I will be what? 1. Then I get incremented by 1, it is 2, j again starts with 2, 0, then 1, and for 2 it is false. Now when it becomes 3, here condition becomes false, because 3 is not less than 3, it is what? Equal. Even you can write down this statement like x of ji, it also do not matter. So at that time what happened? It will put a value at 0, 0th location, means first value goes here, then 1, 0 position means second value goes here, then 2, 0 position, then third value goes here. Okay, just you are fetching the element in a different way. It do not matter how you access the element, row wise or column wise, it is definitely your choice. But in memory it get represented what? It get represented row wise. Okay, similarly we will see the output statement also. Now let us see how to print the content of array. Again, it is your choice whether to print it in row wise or column wise. Here I am going to show you how to print it row wise. Means first of all 15 and 2 get printed, then 9 and 7 get printed, and then after 6 and 5 get printed. So again I have to print it in 0, 0, 0, 1, then 1, 0, 1, 1, 2, 0, 2, 1. Okay, in this way. So here I will say for I equal to 0. So definitely we have to use nested loop. So remember this thing, that for one dimensional array we have to use single loop, whereas in case of two dimensional array we have to use nested loop. And nested loop for combination of a combination of two nested loop. Now here I'll say printf %d, just put a space here, then say x of ig. Okay, see here also we have to specify array name along with its row index and column index, and then after when you complete the inner loop, at that time don't forget to give a new line, otherwise all the element will appear on the same line. Okay, so let us revise this part quickly. So first of all we saw how to declare multidimensional array. This is nothing but a dimension. When you increase this dimension, that is nothing but a particular dimension of your array. Like this, here we define 2 dimensions, so this is 2D array. Here we define 3 dimension, that's why it is 3-dimensional array. And as I told you, we are going to focus on 2-dimensional array only. So in 2-dimensional array we saw how to declare 2-dimensional array, what this 2 dimensions represent. First represents row, second represents column, and if you take a multiplication of these two value, it will gives you the total number of element in your array. This is the conceptual representation of array for our purpose, whereas in memory it get represented consecutively. Means contiguous block of memory get allocated, and again it get allocated row wise. That's why this special representation is called as row major representation. Now whenever I want to access any value of the array, I have to specify 2 indices. First one is row index, whereas second one is column index. Remember this thing, first index is always row index, whereas the second index is a column index. Then we saw how to took a input. after that we saw the initialization part, then we saw how to take an input. Okay, again there is nothing special or something different. You have to scan it in the same way as you scan the simple variable, but just you have to mention the indices of the array, and here you will specify the 2 indices. Now since here, as you can see, our ith value or row value is remaining fixed for the different column values, and when again row value changes, my column is again starting with 0. So for this purpose we have to use nested loop. Again I'll repeat, you can scan it in either order. You can say x of ij or x of gi. Okay, first index will be always considered as row index, so according to that it will perform the operation. Now then we saw how to print an array using printf statement, and there also we use nested for loop. Now from next video onward we are going to see the programs on 2-dimensional array. Thank you.